Okay, thank you, Yishan, for this kind introduction. I apologize up front. I am an architect, so I'm not core roboticist. So I think many of you probably have much smarter ideas and methods and technical skills to solve what we're trying to solve. I'm presenting today one topic which we have recently started, or like started 1 year ago with Begum, who is also sitting here, which we refer to as Unbuilding. Robotic disassembly methods enabled by spatial AI and mobile robotics. And in a larger set, we're looking into not just how we can construct buildings robotically, but how can we take buildings apart using robotics. This project is a collaboration set up here at TU Munich. Between my professorship and the professorship of Stefan Leutenegger, Machine Learning for Robotics, and has been running for about a year. 2 PhD students are working on it, Begum Saral, who is here, and Hanji Chen, who is not here today. So in 2021, this number, 54% of the gross waste generated in Germany was construction and demolition waste at 222 million tons. This is a lot of building material that turns into construction waste and never gets another chance to be part of the built world. Current linear approaches in building construction involve demolition with destructive machinery, resulting in large amount of construction waste being discarded in landfills. This is today preferred because it is cost-effective, labor-saving. However, it undermines the potential of reusing building material as they cannot be retrieved as intact components. So on the other hand, if we would carefully deconstruct our buildings, it involves the reclamation of materials in their entirety through disassembly. But this is very challenging considering the complexity of modern building technologies. Our buildings are glued, screwed, and you can, just look around. And this is very challenging. However, had we developed a technology that we can retain a significant portion of this currently discarded material, we could reintegrate them into the building cycle in a much more effective way. And this is exactly what we are trying to address with this topic. How can we deconstruct existing structures responsibly to reclaim and regain materials and also the embodied energy that is in them? And then, of course, how can this be enabled by robotics and AI? And how could these new technologies help us to address this problem in a completely new way? So in order to address this problem, we have set up a series of experimental studies. We will first look into robotic disassembly routines for material reclamation, and at a later stage also to work with these reclaimed materials to kind of introduce them into a new building. And currently, we look into this disassembly routines, and we are working on it for a year only now, but it has opened up a complete different way of how we think of construction. I think we have heard today this assembly through disassembly for learning methods. It's something that also we thinking about disassembly actually makes us think completely differently of assembly as well. And we have set up 2 case studies in that regard. One very easy case studies, like with very limited complexity, such that we can sort of explore the problem from a different perspective. One is disassembly of dry stack brickwork. So it's really, there's no gluing or anything. It's just like dry assembly. And expanding this currently also to deconstruct bricks that are more bound with mortar. So this looks like this. Our experimental setup looks like this. So you can see here, first case study where we explore the disassembly of a dry stacked brickwork with unknown geometry. So it's just like assembled manually in front of the robot. And then expanding that to robotic disassembly, where also the bricks are in a mortar, bounded already with mortar. We have developed a end effector for that. So in the first one, pretty simple. In the second one, a little bit more elaborated. So in the first one, we had a vacuum gripper with a camera mounted, and in the second one, we have changed to a parallel gripper a camera setup and a drill to also take away the mortar. So why is this difficult? So in contrast to a typical assembly setup, we have, or at least in architecture, probably in your case a little bit different, we have a given set of materials and we have a target state or a goal state with which we want to assemble the material to. In this assembly, it's different. We don't know anything about the geometry of the assembled part, but we want to kind of detect it, and then we want to go back to this kind of storage situation, basically. So we developed a method that consists out of object detection to detect discrete objects in a given structure with photorealistic data generation for learning to detect these objects. And then we have looked into developing manipulation routines for disassembly, and also how we can basically generate a digital model while we disassemble a structure. No? So we have no model before, but we have the model after, basically. And of course, as we have heard today also many times, given the data intensive nature of such deep learning based approaches, lacking readily available data sets in building construction. So there's no readily available data sets for bricks. We have been setting up basically this render pipeline featuring randomized settings for the overall geometry. So this kind of baseline curve, the height of the bricks, different brick materials, damaged bricks, residual mortar, as well as variations in cameras and lighting conditions, basically generating this this photorealistic data set. We have also now been trying to augment this also with real world data. Currently, we're working with the rendered data. Then this is what our collaborators are developing with Stefan Leutenegger. Taking this color data from the RGBD camera is fed to an object detector to detect and segment individual brick objects, and using this segmentation as well as depth data, the poses of individual bricks are acquired, no? Eventually helping us to detect arbitrary objects with arbitrary sizes and colors and also occlusion with residual mortar. So so this are just some images of current tests that we are doing. So it allows us to accurately identify and estimate the poses of individual bricks within a structure that we have no knowledge about on the geometric configuration that is also partially occluded by the mortar, and we do then some post-fusion to obtain their precise position. Now, having this kind of object detection within a structure, how such a deconstruction process starts is that we first take an initial snapshot and we scan kind of to detect where is our object, basically. And then we have a iterative routine where we then obtain always a refined kind of estimation of individual bricks. Then we kind of derive from that, either if there's mortar or no mortar, we have different then manipulation routines where to kind of drill the mortar joint and then how to kind of break the brick apart. And this then goes as long until the full wall is disassembled. So this is how the fine-tuning is taking place. So you can see here, probably not very easily, but you can see here, once we have sort of detected where the wall is, we go a little bit closer and then we detect the final image. Then you can see here the drilling operation. So we have some planning in the background that kind of plans the motion for this drilling operation. And of course, you can see here we also, like we could run due to the tolerances in the structure to some kind of, or post deviations to run into kind of some collisions. So we are also developing some force control in order to kind of also deal with estimations. Then the gripping is also, of course, the estimation is, I can later give some numbers, plus minus X millimeters. Then the position is refined by finding the X position precisely. And then after that, bricks are basically placed back to the storage. No? So I can give some results on this kind of methodology. The first one is where we had the kind of dry stacked brickwork. You can see here how the single bricks are obtained, and then how the motion is planned to put them back into a storage actually at the backpack of the robot. And how, without any prior knowledge, this brick wall can be disassembled. In this case here, all the bricks in reach are basically disassembled. Then we manually move the robot to another position and kind of start the same thing there until we can until sort of none of the bricks are left. So in this case, we relocated 5 times. Am I running out of time? No, okay. Relocating 5 times, and the whole brick wall could be disassembled. Yeah. And what is extremely nice, I mean, this is also like somehow we kind of just found this while we started to do this, is that, of course, as you're disassembling, you kind of create a digital model of what you have built before. No? So if you think of deconstructing, you could actually kind of also use this for reconstructing if it were to be some valuable building that you may want to rebuild. So in this case, we had 58 bricks. They were all, we had 100% success rate, because of course it's very simple. And we had also the vacuum gripper that could take a lot of tolerances, let's say. Of course, it's a very slow process. We had like kind of things would need to be highly parallelized. But you can see here how this whole brick wall could be disassembled from 5 different locations. And now moving to the second case study, which we are currently working on. So these results are very preliminary. Our success rate is not as high, of course, because we have already much more difficult situation of having to detect these bricks, although they are partially occluded. Yeah, and here are some numbers. So from the first snapshots, we get so around ±2 centimeter accuracy. Then when we go closer, we can go below 1 centimeter in estimation, and that is a good enough estimation, let's say, to then work with the rest of the disassembly routine. Yeah, so in conclusion, we have demonstrated the effectiveness of deep learning-based vision perception methods in order to facilitate robotic disassembly. I'm sure there would be much more now interesting approaches with these sim2real approaches that we have seen before to address this problem. But we have introduced an approach for generating an S-progress digital twin as a result of the disassembled structure. And we could apply some synthetic photorealistic data generation in order to train these kind of models for construction materials, which is somehow not there. There's a lot of limitations, of course. So there's limited robustness due to the specificity of the object perception system. So transferability to other types of construction materials and so on is a big topic. Then, of course, the routine itself has limitations. So, of course, there's many different ways how to disassemble, and also brick disassembly is different to when you look around to any other disassembly routine. And of course, we are lacking empirical evidence for the CO2 emission reduction if we were to kind of apply this to a real-world construction or deconstruction scenario. So outlook, it would be interesting to also do to apply machine learning methods in robotic manipulation processes by leveraging human action learning or skill learning, and to develop a comprehensive pipeline for disassembly, brick cleaning, packaging for a full mobile construction setup. If you know a building that you want to deconstruct, let us know, because we are also looking for real world application scenarios to address this. Yeah. Okay. So that's it. Yeah.